Hello, good morning. My name is Pablo Villada, a student of course accounting and budgeting, and today I will be talking about a very interesting article titled Algorithm that executes submodel of a mathematical model of greater efficiency. The main reason I chose it is that it focuses on the financial structure we can find today in the different business models of national and international economies. First, we will begin with the abstract and then detail several factors. Farming service called FLAG, cash flow in agribusiness, that offers in clients mathematical models consisting of his down variables and wells that's ordered from his business environment. Flag obtains update values to the letter with the frequency determined by the client and computes the values of the other variables, thus providing the client with the impact of the change in the indicators and included in this model. The method uses to increase the efficiency of the calculation of a mathematical model containing a number or a formula through which the values of these variables are computed and described. It consists of operations to be performed on its operand variables of the models. The need to the reduced processing time results from processing of several models, where the total duration is limited by constraints of the system that invoke such instructions. The algorithms are built to minimize input-output operation. Additionally, whenever the model is invoked by a change of a single variable, only the submodel consisting of the variables that were directly and indirectly affected by the change are calculated execution of model prepared to confirm the efficiency to the improvements show reduction of up to the need to minimize the execution time of mathematical model arose from a service called Flash cash flow in agribusiness described by Howard Mengelberg 2012. This service is offered to various clients who formulate a mathematical model comprised of their own variable, VCL clients variables, and variables from their business environment, VMR real world variables. The service consists of obtaining update values for the VMs and recalculating the variables using by the client if their models. According to Gapkowski, 2005, the attributes that such service requires in the information this provides to its client include, among others, interpretability, significance, timelines, and credibility. However, the fundamental attribute is that the information be timely and actionable, meaning that the recipient can use the information in a timely manner. Incorporating obtainable data into a model allows precisely that, communicating to the client the impact of change on their activities. Generally, the service offers a set long variable research models means to any client who needs them. When some request a new VRM is added to the set, search agents are also defined, which will obtain update values for the variable from those published online and the required intervals. When the values of sometimes variable change, the model that incorporate the affect variables and execute. The model contains calculate variables whose values are obtained using a formula defined of the purpose. This formula uses other variables both from the client and from the real world. As operant, details of the formulas are provided below. In this way, each client updates a database with their variables and formulas in addition to obtaining the values of the below variables, which are those without a formula. For example, the values from the hectares to the zone for month are entered. This value will be used in a formula for another variable. That is as harvest will the number hectares multiplied by yield for hectare. When the yield can be calculated values based on variables such as climate, seed type, fertilization, etc., or another vector from below. The situation projection flag showed that servers can be provided to many clients, where the quantifier will depend on the context of type of computer equipped used thereafter. It when the agents detect changes in VMR values, a large number models are sometimes executed. Therefore, the duration of this process must be short enough for the completion before creating the need to run other models as a consequence of new changes detected in VMR values. Since agents are launched without interruptions, FLAM flag has a series of mechanisms that allow to know which models need to recalculate given the change in VMR values. A process launch agents program the retrieve data from Wenchpaint and periodically, typically every minute, notifies another program of this is by each client to determine if any of the chain require recalculating their model. For the affect models, the formula execution program is invoked, recalculating and re-recording the values of the affect variable for each model. Materials and methods. The tree has a data structure. In mathematics and computer science, a connect graph is a set of objects called nodes, linked by connection called edge of iris, which allow the representation of binary relation between elements of a set. One of the most widely used data structure in the tree which defined as a connect graph without loops, also called cycles. According in Ways 1992, a tree consists of a distinguished node called the root, with zero or more subtrees, type 1 and type 2 and type k, whose roots are connected by and direct to R. In this work, the following terminology was adopted: subnodes, connect to a node, leaf, a node with no subnodes. The maximum number of subnodes a node can have between a node and a subnode. There is a relationship called parent-child. In Flag, the term parent was replaced with that because the first version of the package were developed in English. Flag is used to illustrate the concept of progress efficiently. To describe the use of submodel winning of a model, it was considered appropriate to present in a context of information service called FLAG, cash flow in agribusiness, that provides its clients with real-world data their business environment. As noted in Figure 1, it is composed of modules that together provide the service. The main concept that defines this service is the client's model where all progress takes place, including communication between the client and flag, queries, variables updates, and the execution of a model's formulas. Flag was conceived as a service for multiple clients, each of the volumes a model of the type described above. The service provides update values of various real-world variables, RMBs, and each client can include some theirs in their models. For example, a producer can include the price of the input in the model. The service will then have agents that require intervals will obtain the updated price value from the specified source of the variable. As a part of the specification, each client provides what are called execution criteria. To do this, they indicate the real-world variables in their model. Those whose values will trigger the model to run when they change. This allows them to determine the impact of change of their activity indication. The criterion formulate of a RBM is specified as a range around the previous value. That is the new values of assigned this range. The model will run. The range can be specified by their endpoints or as percentage change detected in the obtained values. For example, it can be specified that if the change value is less than 1 or greater than more 2. The model's roof of the same can be done, but providing percentage and the previous value given that the service of many clients change is by VM. Values can result in the execution of a large number of models, since the time available for execution is limited by the frequency with which change in real-world variables occur. Therefore, the efficiency of the process is crucial. This is the reason for the research described here, which say ways to improve the process in any way that result is greater computational efficiency. Conclusion from the text. The text describes the design and operation of the flag system and leads to several key conclusions. First, computational efficiency is essential. The main motivation behind flag is to improve efficiency, since many clients and variables are involved. Small changes can trigger numerous model executions. Sub-optimizing performance is critical. Conclusion number 2. Selective execution instead of a full recalculation. Flag avoids recalculating the entire model every time. Instead, it executes only the necessary parts of models depending of which variable change. Conclusion number 3. Use of submodel for optimization. The system builds submodels that include only the variables affected by a specific change. This significantly reduces computation time. Conclusion number 4. Tree structure simplifies processing. Models that transform it into a tree structure too ensure correct execution order, identify dependencies, and facilitate submodel constructions. To achieve this, synonyms are introduced so that a variable does not belong to multiple formulas directly. Conclusion number 5. Avoidance of error and ambiguities. Flags prevent circular reference and ensure correct calculation ordered by assigning labels to formulas to dependence are always compute first. Conclusion number 6. Optimization using additive operands. The system distinguishes between additive and non-additive operands. There is a chain of code in an additive operand. The result can be updated using only difference. This avoids recalculating the entire formula and improves efficiency. In conclusion, we can say that the flag system represents an interesting proposal for improving the efficiency of handling complex models, especially in environments where data is constantly changing through the use of submodels through structure and optimized calculation. Computational costs are reduced without sacrificing accuracy of the results. Furthermore, a flexible design allows it to adapt to different users' needs, making it a tool with great potential for decision making. Thank you for your attention. I hope this presentation has been clear and helpful. I am available for any question or comment.